Hello everyone, this is Dr. Rahul Pethe. As we see the title NodeMCU and Soil Moisture Sensor, we know very well about that NodeMCU, pin configuration of NodeMCU, and in the previous lecture we already discussed about the few other different sensors are nothing but your touch sensor, are nothing but your, I can say, a particularly DHT11 sensor. As we know about that gas sensor, these are the different sensor as already discussed in the previous lecture. So about that new, I can say that the soil moisture sensor. Here we observe that soil moisture sensor measure moisture content in the soil. It comes to with two electrodes that can be dipped into the soil. As if there is in a moisture in the soil, it complete the circuit with the two electrodes. It means whenever the soil is available in a moisture is available in a soil, then that two electrode will get generate the signal, and that signal, that means the sensor sends the output signal to the microcontroller when moisture is detected in the soil. As we know, each and every sensor have either 3 pins or the 4 pins. Here as it observed that soil moisture sensor have 4 pins. VCC is connected to the VCC terminal of a NodeMCU, ground is connected to the ground terminal of a NodeMCU, and as we see here we have a D0 and A0 pin. D0 is a digital out, A0 is the analog out. As we know very well that if we want to use this sensor as a digital sensor, then the digital pin goes high when moisture is detected in the soil, otherwise it remains low. And if we don't want to use as an analog sensor, then that A0 pin it is not in use. So we can make the connection as shown in the circuit diagram. Here we have a soil moisture sensor. Soil moisture sensor have 2 electrode, and that 2 electrode is get connected with this particularly pin number D0 as GPIO pin 10, and the VCC terminal is connected to the VCC pin 3.3 volt. Ground terminal is connected to the ground pin, and last pin A0 pin is not in use. As the moisture is detected in the soil, then that particular 2 electrode will send the signal to the microcontroller, it means to the NodeMCU 8266. Then their output, as we see here, we have a LED connected as an output and connected to the GPIO pin number 14 through 330 ohms resistor. So it work as an output, and soil moisture sensor work as an input. So it will detect the soil moisture in a soil, then the LED will goes high. So this is the basic concept of our particular program. So what we can do, we can just define the pin number for that particular input device and output device. Input is nothing but your soil moisture sensor, and output is nothing but your LED. So as we see here, we can define the pin number, and the name of that particular pin is soil pin 10, means the soil moisture sensor connected to the 10 number pin, and define LED pin to the 14 number pin. It means it work as an output. The LED is connected, positive terminal of LED anode terminal is connected to the pin number 14. That can be initialized, and their output is observed on a serial monitor. So here we can initialize in a serial monitor with the open parenthesis and close parenthesis. Serial dot begin 115200 indicate that the data baud rate of the signal is generate the statement the soil detected or soil not detected, moisture detected, moisture not detected on a serial monitor of Arduino software through a baud rate of 115200. We can also initialize the sensor pins. Sensor pin means through pin mode. So soil pin, which is already connected to the pin number 10 in pin number 10 in your hardware, work as an input, and LED work as an output. So we can mention pin mode LED as an output. Now as per the function, if the soil is moisture is detected, then LED will goes high. If so, we can put up the condition. So that condition is called in the soil moisture sensor loop. So we can call a void loop. In the void loop we'll call a soil moisture sensor loop. So while soil moisture sensor loop will start with this open parenthesis, and then we'll have a condition. If digital read soil pin is equal to low, means then serial print soil is wet, then LED will go high. LED will get high for the half second. Here we can see that serial.println is indicate that that information is available on a serial monitor. It indicates soil is wet. Then digital write means LED is work as an output. LED will go high. That LED will goes high for a half second. If the digital read soil pin indicates that the output is high, means the soil moisture output will come high, then it will print as a serial print soil is dry, then LED will get low, and that low LED will low up to the half second. So this is for the soil moisture sensor connected to the NodeMCU as an input and LED work as an output. So LED glows when you dip the soil moisture sensor lead in the moist cell. As we know that keep soil and water away from the electronic circuit and other water sensitive material around you, so it will protect your hardware itself. So this is all about the soil moisture sensor, which will generate the output. It can be generate the output on a cloud itself. For that purpose we have to connect that generate the data from the soil moisture sensor, give it to the output Wi-Fi device, as an 826 is a Wi-Fi inbuilt Wi-Fi device with a 2.4 gigahertz frequency. Somehow when you are going to purchase the particular NodeMCU, some products are also indicate as a 2.4 megahertz, but better to go for the 2.4 gigahertz frequency. It will be very good and it will be useful for the Wi-Fi purpose itself. So please make sure that if you need to, this is simply to upload the data on a serial monitor or indicate as an LED as an output device. But if you need to upload that data on a cloud, that time it is necessary to upload to require that particular Wi-Fi connection. So this is all about the soil moisture sensor with the NodeMCU. If you like this lecture, please like and subscribe my YouTube.